Hello everyone, this is our 34th video tutorial under the GCSE topic revision guide called Recurring Decimals. As very minimal amount of theory behind this topic, we will do some exam style questions and get practice with some couple of questions, then you may be able to understand this topic. This is the tutorial we are going to discuss in this video session. You can download this tutorial from our website at www.smarttutorscom.uk/worksheet.php, or you can follow the link in the description to get the tutorial in PDF format. If you are following the website under the Year 11 section, you can download this tutorial. Let's look at some exam style questions. Question number 1. Express the recurring decimal 0.3.9 as a fraction. So let's introduce this one. So first of all, my first step is I'm going to assign that recurring decimal into x. So x equals 0.3.9. So the way to do is you need to expand this recurring decimal in the normal format, which is x equal 0.3 and 9 recurring. So 393939 ... Right? Now, what you want to do is you have to multiply this one by 10 or 100 or 1000. Make sure the decimal part comes as the same number, 39, 39, 39, so repeating one. If you times by 10, so this side is going to be 10x equal, the decimal will move one jump. So that becomes 3.939393. So that is not the way we want the format. So I'm going to times it by 100, which is 100x. So what I'm doing, I'm timesing the first by 100, so 100x equal, the decimal point is going to be jumping two places. So 39.3939. Now if you call this as a question number 1, this is number 2. So 2 minus 1. 100x take away x is 99x equal 39 take away 0 is 39. All the decimal parts will cancel with the decimal parts here. So you make sure the decimal parts are equal. So the x equal 39 over 99. If you simplify by 3, that is going to be 13 over 33. That is the answer for the Part A. Part B, express the recurring decimal 0.4.5. Let's assign this as a x. It's a separate question. 0.4.5. So if I expand 0.454545 ... it's continuing. So I'm going to do the same thing. 100x equal 45.454545 ... This two decimal jumps, so that's what the 45 comes. Now take away one from the other. So I'm going to take away from 2, take away 1. So 2 take away 1 gives 99x equal 45. So x equal 45 over 99. So divide by 3 is 15 and 33. That is the answer for the B. And the C part, using the part A and part B, express 0.3.9 plus 0.4.5 as a mixed fraction. So we'll see is mixed fraction coming or not. This is equal to 13 over 33 plus 15 over 33. So you can add these fractions, so 28 over 33. That is the answer for the question number 1. Question number 2. express the recurring decimals as a fraction. So x equal 0.21.3. Careful, here the digit 2 is not reoccurring, only 1 and 3 are recurring. So x equal 0.213131313 right? Now we need to check if I times by 10x, the decimal is going to be moved one jump, so that is equal to 2.131313. If I times by 100, just checking 100, what will happen? This decimal moving two decimal, which is 21.313131. If I times by 1000 x means, so that is going to be 213.131313, right? So if you look at this equation and this equation, the decimal part is going to be same, 1313 same. So 1000x take away 10x is 990x equal 213 take away 2 is 211. So the answer is x equal 211 over 990. You can leave it like that. That is the fraction equal to that recurring decimal. Question number 3. Prove that 0.473, 7 and 3 are recurring. So first expand that once. X equals 0.4 is not recurring, 73, 73, 73, First times by 10x, which gives 4.737373, times it by 1000x, which 3 decimal jump 1, 2, 3, so which is going to be 473.73. You may now understand what I am trying to do is the decimal part has to be same. So here 1, here 2, so 2 take away 1, so 1000x take away 10 is 990x equal 473 take away 4, so 469. So 990x equal, that means, so x equal 469 divided by 990, right? So that is the answer for the question number 3. Question number 4. Prove that, so x equals 0.1 recurring, 7 recurring. So x equals 0.171717, right? So that is the answer. So I'm times it by 10 and see whether anything happening. 1.7171171, and if I times it by 100x, it's going to be 17.171717. So if I name this as a equation 1, this as a equation 2, reason why, the decimal part is 1717, here also 1717. So take away 100x, take away x is 99x equal 17 take away 0 is 17. X equal 17 over 99. That is the answer for the question number 4. So you have proved that fraction, that recurring decimal equivalent to the 17 over 99 as a fraction. Question number 5. Change the recurring decimal to a fraction. Again, same thing, 2.2.3. So that is x equal, so you're going to be expand this one, x equal 2.23232323. So that is reoccurring. And how I'm going to do is I'm going to be times by 100. So 100x means 2 decimal jump, 223, right? 223.232323 dot. The decimal part is same. So 100x take away x is 99x equal 221. X equal 221 over 99. So x equal, you need to make it as a mixed fraction, 299. So 2 times 99 is 198. 221 take away 98 is 2 plus 8, 11, 10, 3, 23. That is the answer for the question number 5. Question number 6. Prove 0.72 recurring. So 0.7 dot 2 dot. So x equal 0.727272 dot. So 100x equal 72.727272 dot. Take away one from the other. So make sure the decimal part same. So 99x equal 72. So x equal 72 over 99. If you divide this by 8 or 9, if you divide top and bottom by 9, this is going to be 8 over 11. That's what they ask you to prove. That is the answer for the question number 6. Answer is 8 over 11. Question number 7. Prove that 0.0 and a is recurring. So if I assign that is to 0.0 recurring and a recurring, if I expand this one, so 0.0 a, 0 a, 0 a, and dot 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 dot. I'll do the same thing because here they have given a range. A is a 1-digit number in between 1 and 9, right? So do the same thing what we did before. So I'm going to be times it by 100x to make sure I'll get the same decimal answer. So 100x means 2 jump. So the answer is going to be a dot 0a 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 dot 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 dot. So the same decimal part. Take away one from the other. So 99x equal a. So x equal a upon 99. That is the answer for question number 7. A upon 99 is the answer. Question number 8. Write the numbers below in order to start with the smallest. So write the numbers below in order start with the smallest number. So how can I make this as a, first of all, this one we need to make it as a equivalent fraction. So I'm going to do this here. X equal 0.4, 7 and 2 are recurring. So x equal 0.4727272 dot 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 dot. So if I times by 10, 10x equal 4.727272. So the decimal number is 7272 is same. So I'm going to do the same thing here. If I times by 100, that is not going to be helping me. So that will 100 means 2 decimal jump. It comes as a 2727. So I will go for 1000x. That means 3 jump. 3 jump means here to here, which is 472.727272 dot 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 dot. So this is the decimal part is same. So take away 1000x, take away 10x is 990x equal 472 take away 4 is 468 and x equal 468 over 990, right? So that is the answer for this decimal. So how can we make it as a recurring decimal equivalent fractions? We already found. So 0.47 recurring, 2 recurring is equal to 468 over 990. Then the next number 5 upon 11, I'm going to times it by 90 and times it by 90 on the top, right? So 450 on the top, 990. So out of these two numbers, this number is the smallest number, right? And 11 upon 23 comma 5 upon 11, right? So which one is the smallest number? 11 times 11 is 121, 5 times 5 50, 115. So this is smaller, this is bigger. So the easiest way to do, so just to recurring, maybe there's a fraction if you like. So 11 divided by 23, so 0 to 110, and how many times 110 is going to be go is 4 times. 4 times 3 is 12, 4 times 2 is 8 plus 1, 9. So 18, 180 is going to be 8, 108, 7. 7 times 3 is 21, 2 remaining. 7 times 2, 14 plus 1, 161. 161 means 9 and 190. So 190 means this is going to be 8. Exactly. So we've proved this is equal to 0.478. So 11 upon 23 equals 0.478. So this is the smallest guy, which is 5 upon 11 is the smallest guy. Then 0.747 recurring, 2 recurring is the second one. The third one, the biggest one out of the group, is 11 upon 23. So that is the answer. So how we did it? We changed the recurring decimal into fraction. Then we compare this fraction and this fraction. 450 is the smallest. So keep that one and I convert into a decimal, that is 478 something continuing. 478 is the biggest one out of the everything, right? So this is 0.472, right? And this is 0.478. So this is the biggest one, 11 upon 23. Second smallest, this is the 450, is the smallest one. That is the end of the tutorial. If you like to download the tutorial, please follow the link in the description. We can download the video tutorial what we discussed here in a PDF format. Then you can practice the question on your own. If you are referring to our website, under the Year 11 section, you can download the tutorial. I hope you do like our video. If it is benefit for you for your revision, please give us a thumbs up and subscribe to our channel to watch all the future upcoming videos. Thank you.